Okay, so the first thing is this little number right here is called the index, and it's written unless it's a 2. If there is no little number there, then that is going to be a square root. Again, but that's called the index, is the root that you're trying to find. This could be a square root, a cube root, a fifth root, a fourth root, sixth root, whatever we're dealing with. And we will be making a list so that you guys can use that, but you can also do a lot of these if they don't have variables in the calculator, as long as you know how to use a calculator. Okay. X is called the radicand. That's the number that's under the radical sign. And then when we call it a radical, we're actually just referring to that sign. So when you call it an x, or when you say like the square root of 2, okay, we don't want to just call it radical 2, because radical is just a symbol. We need to know what root you're talking about. So we need to refer to it as a square root or a cube root or things like that. Is everybody okay with those? Heard all that before. All right, and we're going to start basic. We're going to simplify or state that it is not a real number. So let me do this. Now, again, you can do a lot of these in your calculator as long as you know how to do the square roots and the cube roots, but we will also have a list that you can use. I don't know if you still have the ones you made before. You can make another one if you need it for your homework. And when we take our quizzes and tests on this stuff, I will probably just put them on the board for you. And for cubes and anything higher than that, we only go a certain height. I'm not going to give you some crazy large numbers, but we'll start with this, okay? So again, if you do not have an index written, then it is understood that that is a 2, just like the exponent on a variable, if it's not written, is understood that it is a 1. So we're going to start with some easy ones. What is the first one asking us to find? The square root of 64, okay? So if you're not sure what that is, which I hope we all know what the square root of 64 is, one way we can use our list is we know it is a square root. So we're going to look at our squares and we're going to go down, and there it is. And so then the square root of 64 is going to be 8. And again, that can also be done in the calculator as long as you know how to do that calculator. Then for number 2, we've got a negative on the outside of the square root sign. So that's like a negative 1 times the square root of 49. What is the square root of 49? 7. So this is going to end up just being what? Negative 7, yep. But then where does my negative move for number 3? On the inside, right? Now, keep in mind, this is the square root of negative 25. And yes, I know we've all learned about the imaginary numbers before, but we haven't gotten to that point yet here. Is there a number that I can multiply by itself to equal a negative? No, because a negative times a negative is a positive, and then a positive times a positive is a positive. So with this one, because the index is even, if it's a square root, a fourth root, sixth root is tricky because it could be a cube as well. But if the index is even and the negative is under the radical, at this point, we're just going to say that that is not real. If you try to do the square root of negative 25 in your calculator, it would tell you there's an error. Okay? So at this point right now, if you have a negative under a square root or a fourth root, we're just going to say that that is not real. Does that make a little bit of sense? And then what changes for 4, 5, and 6? It's a cube root because my index is now a 3, okay? So we're going to want a cube root. Again, those can be done in the calculator if you don't have your list. You just have to know how to enter it into the calculator. But we have our cube list right here. So the first one we want to simplify is the cube root of 27. Okay, so I can, if I don't know my calculator, don't know my cubes, I can go to my list. And then to find the root, I just scroll all the way over to the roots. And what is the cube root of 27? 3. Okay. And then for 5, we have a -1 times the cube root of 8, which is going to be a -1 times whatever the cubed root of 8 is. If we look at our list, here's my cube root of 8. Scroll over, and what is its root going to be? 2. So this is going to be a -2. And then for 63, I have the negative under the radical sign. However, this is not a square root or a fourth root. It is a cube root. Can I multiply a negative 3 times and end up with a negative? Yes. So when you have a cube root of a negative number, you can actually simplify that. What is the cube root of 64? 4. Okay. But if it's a negative 64, then our cube root would be what kind of 4? -4. Because if you think about it, -4 times -4 is a positive 16. Then times another -4 is going to be that -64. So if the negative is under the radical, if it's even, like a square or a fourth root, we say not real. If it's a cube or a fifth root or something like that, the odd, then we can actually simplify. Do you guys remember doing all this kind of stuff? Mm-hmm. So if we're finding the negative, if the negative is under the radical, if the index is even, like 2 and 4, we would say not real. If it's odd, like 3 and 5, we can actually simplify that. We just find the cube root of the number and stick a negative on it.
Can you go back to the picture of
Mm-hmm. All right, so, oh, I didn't make a list of these. We'll do a few of these. That's about as high as I'm going to go probably for fourth roots. So we can add a fourth root to our list. Go ahead and try 7, 8, and 9. Again, it's a fourth root because my index is now raised, or is now a 4, not raised to the 4, but it is now a 4. So we want to simplify. Again, all of this can be done in the calculator as long as you know how to do it in the calculator until we throw variables in it. When we throw some variables in, then it kind of messes everything up as far as the calculator goes. So if you're not sure what the fourth root is, we add a little bit of a column of 4 clouds. Find that number in your column and then scroll all the way over to the roots, and that tells you what the fourth root of that number is. So what is the fourth root of 16? What number do I multiply by itself 4 times to get 16? 2. Okay. And then for 8, if I pick a negative on the outside, does that really change anything as far as working it out? No. So what is a -1 times the fourth root of 16? -2. And then here's the tricky one that we were talking about just a second ago. It is the fourth root for number 9 of what kind of number? A negative, and we say what for right now? Not real. Okay, anytime that index is even, like a 2 or a 4, and the negative is under it, because I can't multiply a negative 4 times and end up with a negative. Yes. Is everybody okay with that? Anybody have any questions before we move on to the variables? Okay. All right, so we're going to start with the square root of x squared. And the variables sometimes throw people off. So we can talk about what the process is, but then I'll also tell you a different way to think about it. So if I think about the square root of x squared, what is x squared? How would I break that down? It's just what? X times x. Okay, so for a square root, we're looking at what number do we multiply by itself to equal the number that's under the radical. Well, what did I multiply by itself? So the square root of x squared is just x. Does that make sense? Here's the way I think about it. Even when it's not written, I'm going to make this a little bit bigger. What is the index there? A 2. Okay, so this is kind of how I think about it. How many times does my index divide into that exponent? 1 time. So that means the square root of that number is going to be x to the first, which we usually just write it as x. Okay, so let's keep that same thought process. For number 11, I have the cube root of x to the 6. We can write it all out, and I will do that in just a second. But if we want to keep along the same thought process here to make it a little bit easier, I want to think about this. My index is 3. How many times does 3 divide evenly into 6? 2. So guess what the cube root of x to the 6 is? X squared. When we did this, I'm going to go back to this one. If my index is 2, that means I want to see how many groups of 2x's I can find. Well, how many groups of 2x's were there in that one? Just 1. That's why our answer was x to the first. Okay? But if it's the cube root of x to the 6, my index tells me how many I want in each group. How many x's do I want in each group this time? 3. So let's think about that. How many groups of 3 did we get? 2. So that's why my answer is x squared. Does that make a little bit of sense if I draw it out like that? Okay. This is the same thing if we just think about like we talked about up there. How many times does 3 divide evenly into 6? That would be the exponent on our answer there. So, try that one. What is my index? 4. So we want to think again. How many times does 4 divide into 12? 3. So guess what my answer is? X to the third. Does that make a little bit of sense? Okay. Ooh. All right. We're going to add numbers and variables now. So we're just going to do the same thing, but we're just going to kind of take it one piece at a time. I want to find the square root of 16x squared. So the first thing I want to talk about is the number. What is the square root of 16? 4. Okay. So think about it like this. We're thinking about it as if we split it up with the square root of 16 times the square root of x squared. The square root of 16 is 4. And what is the square root of x squared? X to the first, right? Because again, my index is 2, and 2 divides into 2 one time. And that's how we would leave our answer. Keeping that same thought process, try 14 and 15. Is looking for the cube root of 64x to the third. And 15 is looking for the fourth root of 81x to the fourth. If you're not sure about the numbers, we do have the list on the board, or you can learn how to do the roots in your calculator. Okay, you're more comfortable with it. We just can't do the variables in the calculator. We can't do the numerical part. So we want to think about it as if we're splitting it apart, doing the numbers, then the variables. So the cube root of 64 times the cube root of x to the third. What is the cubed root of 64? 4. And then the cube root of x to the third is just x, and so we get 4x again. And then for 15, we're looking for the fourth root of 81x to the fourth. So I'm going to look at my fourth column. If I'm not sure what the fourth root of it is, 81 is here. I'm going to go all the way to the root. What is the fourth root of 81? 3. And then the fourth root of x to the fourth is x. Anybody have any questions there? All right, 16 is a little bit different, and there are a couple of different ways we can think about this. I'm going to show you the long way first, and then I'll show you the short way. What do you notice under my radical sign? I have some parentheses with an exponent on the outside, correct? We just finished that stuff. We just took a test on that. So what does it mean if I have a parenthesis on the an exponent on the outside of the parentheses? Where does that exponent go? It goes to both, right? Think about this. It goes to the 8 and to the x. Eight times 8 is 64, times 8 more is, what is that? 512. And then it turns into a problem just like 13, 14, and 15. I want the cube root of 512, so I'm going to look at my cube list. I'm going to go all the way down until I find 512, and the cube root of it is, what did we just multiply 3 times to get? 8. And then I do the variable. What is the cube root of x to the third? X. Okay, so that's the long way. Here's the short way. Do you notice how I have everything in the parentheses raised to the third power back in the original question? Okay. Well, can we do it the same way since all of this is raised to the third? Can we think about this? How many times does 3 divide into 3? 1 time, which means it's going to be one of those things inside the parentheses. It'll be the 8 and the x, but the 1 time. Okay, so that index 3 cancels out that exponent. They divide in 1 time. So what's left is everything that's in the parentheses, the 8x. All right, 17 you should be able to do. We'll talk about 18 in just a second. Go ahead and do 17. Mm-hmm. Absolutely. We want the cubed root of x to the 15th. I don't have any numbers involved, so I just want to ask, how many times does 3 divide into 15? So my answer is going to be x to the 5th. Okay. And then number 18, I've got the square root of a fraction. Okay, so the square root of the fraction, x squared over 16. When you have a fraction under a square root or a cube root or any kind of radical, the very first thing you want to do is split it up. We want to take that root of the numerator and of the denominator. Okay, so it's square root of the numerator and the square root of the denominator. And then I can simplify from there. Do the top part first. What's the square root of x squared? X. And then the bottom part, the square root of 16 is 4. That would be my answer. Once you take the square root 1 time, even if the answer, like that 4, is still a perfect square, we don't simplify it again. This one? Okay, so the only thing is this exponent has to go to that 8 as well. Wait a minute. So I'm going to look at this has to go to all of the exponents here. So becomes that. We multiply those with 1 equals negative. And then do the same thing here. That would be 1 negative. Then from there, you want to move everything that has a negative exponent. If it doesn't have a negative exponent, you don't move it. Does that make sense? Is everybody okay with those? It's kind of easy since it's all perfect roots. Go ahead and try these last two, 19 and 20. Tomorrow we'll get into stuff that's not always going to be perfect roots, but for today, everything that we do is going to work out to be a perfect square root, cube root, fourth root, whatever we're dealing with. It means it's the fourth root. So if you're wanting using this chart, you look at this column. Okay, whatever the index is, you're going to look at the column that says it. With 19 is just like 18 with the exception of it is a fourth root of the fraction instead of a square root. So you're going to do the same thing. Split it up, numerator and denominator, and then simplify each piece. And then for 20, you're going to want to take it one piece at a time. Do the cube root of negative 8, do the cube root of x to the third, and do the cube root of y to the sixth. And the book didn't have a lot of good examples here, so I made a worksheet for you. That's what I'm asking for right now. So starting with 19, my fraction, I'm going to take the fourth root of the top and the bottom. The fourth root of x to the fourth, and then I want to do the fourth root of 16. Starting with the top, what's the fourth root of x to the fourth? 4 divides into 4 how many times? 1, so it'd be x to the first. And then the fourth root of 16, again, if I'm not sure, I have my list. I can go to the fourth root column, I can find 16, and then I can scroll all the way over and figure out what number I multiply how many times. 4 to get 16 is what? 2. And then remember with 20, we want to take it one piece at a time. You can split it up like this if it makes more sense to you to do it individually. You don't have to, but you can. What is the cubed root of negative 8? Negative 2, okay. What is the cube root of x to the third? X. And then the cube root of y to the 6 is y squared. So we get negative 2xy squared for that one.